Square root functions. So the square root function is y equals the square root of x. And the square root function is an inverse of the quadratic function. So let's look at some graphs. So first let's graph y equals x squared. We're familiar with the parabola, but let's just get some points to make sure that we know exactly what it looks like. So -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Plot those points. There's our nice parabola shape. Then remember, if we are graphing an inverse, what we do is we swap the x and y values. So if we swap the x and y values from the green table, we get 9, -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, 9, 3. And if we graph them, we get a curve that looks like a sideways parabola. However, this inverse is not a function because it does not pass the vertical line test. The vertical line can cross this function in more than one place. So we often only talk about the function part of this inverse. So we erase the bottom part, and now we have a function because the vertical line does not cross this function in more than one place. Okay, this is now our domain stays the same. It's from 0 to infinity. Our range now goes from 0 to infinity as well. It's like we're crossing out the whole top part of this table. So now this red function, the inverse function, is not truly the inverse of the original quadratic function, but it is the inverse of part of that quadratic function. So we often will consider only part of that quadratic function in order to be able to look at its inverse function. So now for the original quadratic function, our domain has been restricted to 0 to infinity. Our range is still 0 to infinity. And this, as I again, crosses out the whole top part of the table and just considers values of x that start at 0 and increase. And again, I mentioned this is considered a restricted domain. And the reason why we do that is so that we can get an inverse function and not just an inverse relation. Okay, I want to remind you how to find inverses algebraically. So if we're starting with our quadratic function y equals x squared and trying to calculate its inverse algebraically, we swap x and y, and now we solve for y. So y equals plus or minus the square root of x. Again, to keep it as a function, we're going to ignore the negative part and just consider the inverse to be y equals the square root of x. This is a way of maintaining it to be a function. Another thing I want to review is using composition to verify that two functions are inverses. So if f of x equals x squared with the restricted domain from 0 to infinity, and g of x equals the square root of x, let's form their composites. F of g of x equals the square root of x squared, which is equal to x, and g of f of x equals the square root of x squared, which is x. Both of these equal x, so that means that these two functions are inverse functions. Okay, just a quick review then of the attributes of the square root function. So we've been looking at this graph, and we can see that the domain goes from 0 and goes up to infinity. If we're writing it with inequalities, we would write x is greater than or equal to 0. The range, again, goes from 0 up to infinity. We can write that as y is greater than or equal to 0. The x-intercept is the origin, 0, 0. So is the y-intercept. And then this function has a minimum point, again the origin, Or if we're asking for the minimum value, remember that's just the y value, or 0.